Hi, Assalamualaikum. My name is Nurul Paudziah and today I would like to present to you my final year project entitled A Real-Time Traffic Sign Recognition System for Autonomous Vehicle using YOLO algorithm. But first, let me explain to you what is the project scope of this study. First, this system only applicable for autonomous vehicle, whether it is a semi-autonomous or fully autonomous. Next, this system only focusing for 5 types of warning sign, which are crossroad left, crossroad right, children crossing, and bump. This system also use the video capture device, which is smartphone camera, for the testing. And lastly, mentioned traffic sign dataset are used. Alright, let's not waste our time. Let's move to the slide presentation.
For the slide presentation, as I already mentioned earlier, my proposed study is a real-time traffic sign recognition system for autonomous vehicle using YOLO algorithm. Alright, let's start with part 1 elevator pitch background study. First, what is autonomous vehicle? Autonomous vehicle is a driverless car that are capable of sensing the environment assisted by several systems such as automated parking, crash avoidance, blind spot detection, and traffic sign recognition. Next, what is the problem? As you can see here, there are several of news that has been stated. The accidents happens due to driver's carelessness. Hence, our first problem statement is rises of accidents due to driver's carelessness, not paying much attention on traffic signs. Next, as you can see here, there is a black cool car, there is a small little cute kids waving, there is a children crossing sign. Let's look closer. What is the driver actually doing? Oops, he's using his phone. In this situation, the driver tends to unnotice the children crossing sign, which lead to boom, the worst thing happened. Hence, my second problem statement is distracted drivers tends to neglect traffic signs that lead to road accidents. Next, for the third problem statement is complexity in developing the system using image processing technique, which this is due to the warning sign has the same shape, same color, and similar characteristic. Therefore, our proposed system is a real-time traffic sign recognition system for autonomous vehicle using YOLO algorithm. For the objectives, first, to design a real-time traffic sign recognition system, to develop the design system using YOLO algorithm, and lastly, to test the accuracy of the developed system. Alright, let's move to the part 2, which is technical presentation. For methodology, I'm using YOLO algorithm. YOLO, as cool as its name, which is you only look once, is a clever convolutional neural network for doing object detection in real time. Next, I'm implementing the flow framework, which is used to run architecture of YOLO algorithm. Since I'm implementing the flow framework, programming language that I'm using is Python. I'm also implementing Keras and TensorFlow framework, which used to evaluate and train the neural network model. Lastly, this system is conducted only on a laptop. Let's move on to the workflow of the system. As you can see, we have 3 parts, which are input, process, and output. For the first one, the input is a real-time video input, where the vehicle is embedded with video capture device. For my demonstration testing, I'm using a smartphone camera and put on the dashboard of the vehicle. Next, for the process is traffic sign recognition, where here YOLO algorithm is applied to detect and classify the image of the traffic sign. And lastly is for the output, which is the notification. It will display and alter the detected sign. As in this case, as you can see, the detected sign is a crossroad. Therefore, it will display the crossroad sign and at the same time will utter the word crossroad. Next, let's take a look on a project demo.
For the project demonstration, first I will show you the simple demonstration of the system towards several traffic signs.
Crossroad. Crossroad left. Crossroad right. School children crossing. Caution, pump.
As you can see, the system is able to detect, recognize, and differentiate several types of traffic signs, and next produce an alert sound based on the detected signs. Besides, it seems that the detected sign keeps stay on the screen, as it has been set for half-minute to stay on the screen before it will out of the screen on its own. Next, I'm going to show you the system testing in real time on vehicle.
Caution, pump. Caution, pump. Crossroad.
It shows that the system still works on real-time detection. However, it's noticed that there has a delay of approximately 3 seconds and a frame rate of 2 frames per second. Besides, the system is only been trained for several types of traffic signs. Therefore, it can be seen that there are some traffic signs that are not being detected.
Alright, let's continue with the result and discussion. As you can see here, I'm using a confusion matrix to evaluate the system. 20 testing images from each class is used, which made the total of the testing images become 100. From these confusion matrix tables, the accuracy, the sensitivity, and specificity is calculated, which for the accuracy, 96% in average of the testing images were classified correctly. For the sensitivity, 90% in average of the testing images were correctly predicted. And lastly, 97.5% in average denotes only less than 3% of all testing images were predicted incorrectly. To be concluded, this proposed system that has been developed using YOLO algorithm has successfully worked as a real-time traffic sign recognition. This is due to excellent performance with an average accuracy of 96%, sensitivity of 90%, and specificity of 97.5%. It hopes that with this system, the driver will pay more attention on traffic signs, which road accidents can be avoided and be reduced. In the long run, for future works, first improve the performance by training the model with greater number of images. Next, apply the proposed architecture with processors mounted on system onboard boards so that it can effectively used in other devices. And lastly, apply this idea to other domains of similar characteristics such as navigation system so that this system becomes multipurpose and more useful.
I think that's all from me. Thank you.